Picture this. You are driving west on Interstate 10, cutting through the Arizona desert. It's a clear night. The radio is playing quietly. Out the passenger window, the full moon is illuminating the cactus and the sand, casting that familiar ghostly silver light. It's the same moon that guided the Apollo astronauts, the same moon that Shakespeare wrote about. It feels permanent, eternal. Think of how intertwined it is with our very existence. Farmers use it to mark the harvest. Sailors use it to navigate the dark waters. For millennia, it has been the only light source that allowed humanity to venture out of their caves at night. It is the oldest clock we have. And then, blink. In less than a nanosecond, the light vanishes. At first, you think your headlights flickered, or maybe a cloud passed over. You look up. The stars are there, brighter than ever. The Milky Way is a slash of diamond dust across the sky. But the moon? There is just a hole in the universe, a black void where, just a second ago, a 73 quintillion-ton rock was orbiting. Imagine the scene at 30,000 feet. A pilot flying over the Atlantic suddenly sees the horizon disappear. The shimmering reflection on the ocean that guides visual flight rules is gone. On the ground, automated systems begin to fail. Telescopes calibrated to filter out moonlight suddenly capture overexposed images. Satellites using the moon as a navigational beacon lose their lock. The confusion wouldn't just be visual, it would be visceral. People would pull over on highways. Social media servers would crash within minutes. Where is the moon would be the only topic of conversation on Earth. Consider the financial panic. Within minutes, algorithmic trading bots, which use atomic clocks and precise astronomical data for high-frequency trading, might detect the gravitational anomaly before humans do. Markets in Tokyo, London, and New York would freeze or crash as the variables for time and tide in shipping futures contracts suddenly become invalid. We would see a global economic seizure triggered by an astronomical event, highlighting just how fragile our digital reality truly is. Is it a super-advanced alien cloak? A glitch in the simulation? Or did the laws of physics just break? But while humanity is staring up at the sky in confusion, the real horror is beginning beneath your tires. You see, the moon wasn't just a nightlight. It was a gravitational anchor. It was a pair of invisible hands gripping our planet, squeezing the oceans and pulling on the Earth's crust. And those hands just let go. The Earth, spinning at 1,000 miles per hour, suddenly feels the release of tension. The water in the oceans, the magma beneath the crust, and the air in the sky are about to react violently. What happens next isn't just a bad night. It is the beginning of a new, terrifying epoch in Earth's history. Welcome to the post-lunar world. Let's begin with the most immediate physical force: gravity. We all know the moon controls the ocean tides, but to understand the catastrophe, we need to understand the scale. Imagine the ocean not as water, but as a stretched rubber band. The moon's gravity pulls the water toward it, creating a bulge. As the Earth rotates through this bulge, we get high tides. When the moon vanishes, the rubber band snaps back. This isn't just about water level dropping. It's about kinetic energy. The moment gravity releases, the potential energy stored in those massive tidal bulges turns into kinetic energy. The water has to go somewhere. This creates a phenomenon known as a global seiche. Imagine carrying a bathtub full of water and suddenly shoving it sideways. The water sloshes violently, hitting one side, then rebounding to the other. On Earth, The sides of the bathtub are the continents. The Pacific Ocean, being the largest basin, would see the most violent reaction. A wall of water, confused and chaotic, would rebound from the coasts of Japan and California. We aren't talking about a clean tsunami wave. We are talking about a standing wave oscillation that could last for days. Harbors would drain dry, then flood minutes later. Ships docked in port would be smashed against the seabed or thrown onto the piers. The entire global shipping logistics network, the backbone of our economy, would be shattered in the first 24 hours. Even enclosed bodies of water like the Mediterranean Sea or the Great Lakes would not be spared. They would experience a bathtub slosh on a continental scale, devastating coastal cities like Venice or Chicago that are built precariously close to the waterline. The predictability of the sea would be replaced by a chaotic, churning unpredictability. But here is something most people forget: Earth tides. The moon doesn't just pull on water, it pulls on rock. The solid ground beneath your feet actually rises and falls by about 12 inches every day as the moon passes overhead. You don't feel it because everything around you moves with it. When the moon disappears, the Earth's crust instantly relaxes. This sudden geological exhale would send shockwaves through the tectonic plates. Think of the Earth's crust like a stressed spring. When the moon lets go, that stress is released. Seismographs around the world would light up instantly. Deep-sea pipelines, transoceanic internet cables, and bridges built over fault lines would face immediate stress tests. We could see a global trigger of earthquakes in fault zones that were already critical, like the San Andreas Fault or the Ring of Fire. Dormant volcanoes, their magma chambers sensitive to pressure changes, might suddenly wake up. The planet itself would literally shudder. This shudder would even affect our GPS systems. The global positioning system relies on a precise model of the Earth's shape, known as the geoid. When the crust relaxes and the ocean bulges collapse, the actual shape of the Earth changes slightly. It becomes less oblate. Suddenly, every map on Earth is wrong by a few meters. Self-driving cars, precision agriculture, and military targeting systems would all drift off course until the entire satellite network could be recalibrated to the new, rounder Earth. Once the initial violence settles, the oceans would become eerily quiet. Without the moon, we still have the sun. But the sun's tidal force is only 40% of the moon's. The towering waves of Hawaii? Gone. The famous 50-foot tides of the Bay of Fundy? Reduced to a gentle ripple. The ocean would turn into a placid, almost stagnant lake. And that stagnation is where the real death begins. The ocean is a living engine. The tides are the fuel pump. Tides churn the ocean, dragging cold, nutrient-rich water from the deep up to the surface and pushing oxygen-rich surface water down. This is the global conveyor belt of life. Without the moon, this mixing stops. The oceans stratify. The warm water floats on top, sealing off the cold water below. The first casualties are the intertidal zones. Crabs, mussels, oysters, millions of tons of shellfish that rely on the tide to bring food would die within weeks. The stench of decaying marine life would envelop the coastlines of California, Australia, and Europe. Consider the impact on the thermohaline circulation, the great ocean conveyor belt that includes the Gulf Stream. While driven mostly by temperature and salt, tides play a crucial role in mixing these currents. Without tidal mixing, these currents could slow down or stall entirely. If the Gulf Stream stops, Northern Europe doesn't just lose its fish, it loses its heat. Britain and Scandinavia could plunge into a localized deep freeze even before the rest of the climate shifts. But let's go deeper. Let's talk about euxinia. When the ocean stops mixing, the oxygen runs out. We call this anoxia. When oxygen is gone, ancient anaerobic bacteria take over. These creatures don't produce carbon dioxide. They produce hydrogen sulfide. This gas smells like rotten eggs and is lethal to almost all complex life. We have seen this before. Scientists believe this is exactly what happened during the Permian-Triassic extinction, known as the Great Dying, where 96% of marine life was wiped out. Visually, the oceans would change. The deep blue we love is a sign of oxygen and clear water. As these bacteria bloom, the oceans would turn a sickly, vibrant shade of purple or pink. This isn't just an aesthetic problem. Hydrogen sulfide is a gas. As it bubbles up from the purple sludge, it enters the atmosphere. It is toxic to breathe. Coastal cities might have to be evacuated not because of rising water, but because of poisonous air. The ozone layer, which protects us from UV radiation, is also vulnerable to hydrogen sulfide, so we would be poisoned from below and burned from above. Furthermore, the oceans currently act as a massive carbon sink, burying tons of CO2 in the deep sea. Without the vertical mixing of the tides, this mechanism fails. All that carbon would stay on the surface or be released back into the atmosphere, accelerating global warming at a rate we have never seen before. It's a runaway greenhouse effect, triggered by a stagnant sea. This stagnation leads to another terrifying weather phenomenon: hypercanes. Currently, deep cold water mixes with the surface to cool things down. Without that mixing, the surface layer of the tropical oceans would bake in the sun, reaching temperatures far higher than today, perhaps exceeding 100 degrees Fahrenheit. This superheated water is rocket fuel for hurricanes. We wouldn't just see Category 5 storms. We would see theoretical Category 6 or 7 monsters, storms so powerful they could scrub the coastlines clean, powered by a stagnant, boiling ocean. We aren't just talking about no more sushi. We are talking about a chemical change in the biosphere that rivals an asteroid impact. And there is an even darker consequence. Plankton are responsible for producing 50% of Earth's oxygen. If the plankton die from lack of nutrients, the Earth's lungs begin to fail. While the oceans are turning toxic, the land is plunging into a nightmare of its own. We modern humans, with our cities and screens, have forgotten what darkness truly means. The full moon provides about 0.2 lux of illumination. That sounds small, but to an animal eye, it is a spotlight. Without it, night becomes an absolute abyss. Predators like wolves, lions, and owls would stumble through the pitch black, unable to hunt. Prey animals might experience a temporary population explosion, throwing the food chain into chaos. Let's talk about the DL vertical migration. This is the largest migration of biomass on Earth, and it happens every single night. Billions of tiny zooplankton, squid, and lanternfish swim from the deep, dark water up to the surface to feed under the cover of night. They use the moon as a signal. It tells them when it is safe to surface without being eaten by predators who rely on sunlight. Without the moon, this signal is lost. Does the migration stop? Do they surface at the wrong time and get decimated by sunlight predators? If this migration breaks, the base of the marine food web collapses. The whales that feed on the krill starve. The fish that feed on the plankton die. It is a domino effect that starts with a tiny crustacean and ends with the collapse of global fisheries. And let's not forget the navigators. Dung beetles use polarized moonlight to roll their balls in straight lines. Migratory birds use celestial cues. And the baby sea turtles? We've all seen the footage. They hatch and run toward the ocean, guided by the reflection of the moon on the water. In a moonless world, the ocean is a black void. The turtles would wander aimlessly, heading toward artificial city lights or dying in the dunes. We would witness a generation of species lost in the dark. But it's not just animals. Consider the nocturnal pollinators, moths and bats, which are responsible for pollinating huge portions of our crops, like bananas, mangoes, and agave, rely on moonlight to find flowers. Without the visual cues of the moon, pollination rates would plummet. This would lead to a silent agricultural crisis, where crops simply fail to bear fruit, adding famine to our growing list of problems. Even the plant kingdom would suffer in ways we don't fully understand yet. Recent studies in plant neurobiology suggest that sap flow in certain trees actually pulses in rhythm with the lunar tides. It is a subtle gravitational tug that helps water climb from the roots to the canopy. Without this tug, would the world's tallest trees, like the redwoods, struggle to hydrate their highest branches? We might see a slow dieback of ancient forests, stressing an ecosystem that is already fighting for survival. And what about us? Humans? We think we are immune, but we are not. Think about the psychological impact. For 200,000 years, humans have looked up and seen a face in the moon. It is embedded in our folklore, our religions, and our calendars. Without it, the night sky becomes flat. The depth perception of the universe changes. Crime rates might spike in the total darkness. Traffic accidents would increase, but mostly, a collective sense of cosmic loneliness would set in. We would realize, for the first time, just how alone we are in the dark. Everything we have discussed so far is bad, but humanity could survive it. We have technology. We have grow lights. But now, we must discuss the threat that ends civilization. We need to talk about obliquity, the tilt of the Earth. Earth spins at a tilt of 23.5 degrees. This tilt gives us our seasons. It ensures that the equator is warm and the poles are cold, but that most of the planet is livable. Why is this tilt so stable? Why hasn't Earth flopped over on its side? The answer is the moon. The moon acts as a torque dampener. It is a massive counterweight that spins around us, keeping our axis locked tight. Currently, Earth's tilt shifts very slightly over a cycle of 41,000 years. These are called Milankovitch cycles, and they are responsible for the slow coming and going of ice ages. Without the moon, these cycles go from slow and steady to fast and chaotic. This wouldn't happen overnight like the tides. It would be a slow, agonizing drift over centuries, but the weather chaos would begin much sooner. Without the stabilizer, the Earth creates a climate flicker. Imagine a world where the climate shifts drastically every few decades. You plant crops for a temperate climate, and 10 years later, you are in a desert. This phenomenon is known as chaotic obliquity. It essentially breaks the predictability of the planet. We rely on the fact that next year will be roughly similar to this year. If the axis starts to drift, we could see tropical rainforests turning into arid savannas and then into frozen tundras within the span of a few generations. Adaptation becomes impossible because the target keeps moving. Look at Mars. Mars has no large moon. Its axis swings wildly, tilting from 10 degrees to 60 degrees. If Earth joins Mars in this chaotic dance, we face two nightmare scenarios. Scenario A, the eternal equinox. The axis straightens to 0 degrees. Seasons vanish. the poles freeze permanently, locking up the world's water in massive ice sheets. Sea levels would drop by hundreds of feet. The equator burns under a constant, unmoving sun. The habitable zones for agriculture shrink to narrow bands in the mid-latitudes. Humanity would be crowded into these thin strips of life. Scenario B, the Uranus scenario. The Earth tips over to 90 degrees. This is hell on Earth. The North Pole points directly at the sun. Imagine a summer in New York where the sun never sets, not for a day, but for months. Temperatures would soar past 130 degrees Fahrenheit. The ice caps would melt rapidly, drowning the world's coasts. Then winter comes. 6 months of absolute darkness. Temperatures plummet to Antarctic levels. Civilization is built on the assumption that spring will follow winter. If that promise is broken, agriculture collapses. We become a nomadic species, chasing the twilight zone between burning heat and freezing cold. And consider the Coriolis effect. If the tilt changes, the way the Earth spins relative to the sun changes, which alters global wind patterns completely. In an extreme tilt scenario, the trade winds that guided Columbus and the shipping lanes we use today would disappear or reverse. The weather map wouldn't just change, it would be erased. We would need to relearn the physics of our own planet from scratch while trying to survive on it. While the axis shifts, the atmosphere itself would change. Currently, the moon is slowing Earth down. Through tidal friction, it acts as a brake, adding about 1.7 milliseconds to our day every century. Billions of years ago, a day was only 6 hours long. If the moon vanishes, the braking stops. We are locked into a 24-hour day forever. But consider the atmospheric tides. Just as the ocean bulges, the atmosphere bulges too. The moon drags a wave of air around the planet. This helps regulate the distribution of heat and rainfall. Without this, the global wind patterns, the jet stream and the trade winds, would become unpredictable. We rely on these winds for transcontinental flights and for bringing rain to our crops. If the jet stream stalls, weather systems get stuck. A heat dome over the Midwest wouldn't move for weeks. A hurricane in the Atlantic might just sit there, churning until it runs out of energy. The predictability of our world vanishes. But more frightening is the magnetic field. Some geophysicists believe that the moon's tidal pull on Earth's liquid outer core helps drive the dynamo that creates our magnetic field. This field is our shield. It deflects the deadly solar wind and cosmic radiation. Without the tidal heating from the moon, could the core eventually cool and slow down? If the magnetic field weakens, we lose our force field. The solar wind, a stream of charged particles from the sun, would begin to strip away our atmosphere, molecule by molecule. First, the ozone layer goes, then the water vapor. We would see the first signs of this not in the atmosphere, but in the sky. The auroras, the northern and southern lights, would no longer be confined to the poles. They would drift toward the equator. It would be beautiful, terrifyingly so. Seeing an aurora over Jamaica or Singapore would mean the shield is failing, and deadly radiation is pouring down on populated areas, frying our power grids and electronics before it even starts on our DNA. There is also the matter of space debris. The moon acts as a gravitational vacuum cleaner, absorbing or deflecting many asteroids and meteors that might otherwise hit Earth. Its pockmarked surface is a testament to the blows it has taken for us. Without this cosmic bodyguard, the probability of an asteroid impact on Earth increases slightly. It's not a shooting gallery. but the odds of an extinction-level event just ticked up. We are now a smaller target in a larger, emptier field, but we are also a target without a shield. This is exactly what happened to Mars billions of years ago. Mars used to have water and air. Then its core died, its magnetic field collapsed, and the sun stripped it bare. Without the moon, this could be Earth's destiny, a cold, red, dead rock floating in space. As we reach the end of our simulation, the picture is clear. The moon is often seen as a mere decoration, a pretty light in the sky for poets and dreamers. But it is so much more. It is a shield. It is a stabilizer. It is the engine that drives the very rhythm of life on Earth. If it disappeared tonight, we might survive the initial chaos. We might endure the floods and the darkest nights, but we would witness the slow, inevitable decay of the world we know. The climate would collapse, the seasons would vanish, and the oceans would stagnate, turning into silent, toxic graves. Civilization, built on the predictable cycles of nature, would slowly crumble under the weight of a chaotic sky. We live on a fragile blue marble, spinning in a hostile, empty void, and we are incredibly lucky to have a faithful companion holding our hand, keeping us steady and keeping us safe. This gravitational dance between the Earth and the Moon is a delicate ballet that has lasted for 4 billion years. It is a relationship of perfect tension and balance. To lose it would be to lose the choreography of life itself. Thankfully, the Moon isn't going anywhere anytime soon. It is slowly drifting away from us, spiraling out into the darkness at a rate of about 1.5 inches per year. But the bond between Earth and Moon is strong enough to last for billions of years to come. So the next time you find yourself walking under a clear night sky, take a moment to look up. Don't just see a cold, gray rock. See the heartbeat of our planet. Think of the footprints left by Armstrong and Aldrin in the Sea of Tranquility. In a moonless world, those footprints, the ultimate symbol of human achievement, would vanish along with the history they represent. The Moon is not just a rock. It is a museum of our greatest journey. To lose it is to lose a part of our soul. For now, the tides will roll in. The sun will rise over a stable horizon, and the night will not be entirely dark. In the vast, chaotic silence of the universe, it is good to know that we are not dancing alone.